Good morning, everyone. My name is Dr. Lisa Galea, and I'm the Family Chair in Women's Mental Health and Senior Scientist at the Center for Addiction and Mental Health, or otherwise known as CAMH. I'm also the scientific lead for CAMH's womenmind and for the Women's Health Research Cluster, which recently established an alliance with CAMH and womenmind. I'm a proud and staunch advocate for the need for more research on women's mental health. For centuries, as many of you know, women's mental health research has been undervalued, underfunded, and understudied, resulting in women experiencing dismissal and denial of their symptoms, leading to a delay in diagnosis across a number of disorders, including mental health disorders. That's really why I'm thrilled to be here today and welcome each and every one of you here in this room and also virtually online to this, our inaugural Women Mind Conference, dedicated to advancing the mental health of girls and women. We are sold out. I didn't get the more. Last count I had was over 350 registrants. I have no idea how many countries, but oh, it's higher than that, 450. 450. And we were sold out in person within 6 weeks. So just that to me indicates the real thirst for this kind of knowledge. And I'm really proud to be part of it. And honestly, planning the content for this conference was a dream come true. And I'm just so honored to host this conference and all of you here. And it's brought to you by the generous community of Women Mind donors. So what is Women Mind exactly? It's a community of thought leaders, philanthropists, and scientists, all dedicated to three things: closing the gender gap in the sciences, advancing women scientists, and promoting and advancing research on women's mental health. And it wouldn't have been possible without the over 100 Women Mind donors that we have currently. But I really want to thank our two founding visionary donors, for which the community was made possible to even start. And that is Sandy Treliving. And she'll be giving some remarks in just a minute. And also the Hudson's Bay Community Foundation. So thank you so much. Our goal here today is to bring together experts in women's mental health to learn and explore why we need a lens on the unique challenges in girls and women, what we can gain when we're using sex and gender analysis in our modeling and our data interpretation. We will also have talks focusing on intersectional factors, and I see some of those speakers here today, talking about reproductive age, stage, lifestyle factors, race, ethnicity, sexual and gender minorities. These types of studies will all contribute to the development of effective treatments to foster a healthier society. I also want to really make it clear that any discoveries that lead to improvements in women's mental health will lead to discoveries to improve health for all, regardless of our gender. Really, that's the promise of precision medicine and personalized medicine. I was in Ottawa recently, and for those of you that are not Canadian, Ottawa is like our seat of our federal power. And they kept talking about the need for more training in women's mental health, which is absolutely true. However, I want to make it really clear, this is a research-focused conference, and we need the research. If you think about it, our healthcare is like our boat. Our healthcare providers are like our crew. And without the research, which is our compass and map, we can't tell our healthcare providers where to go. So that's why it's so important to concentrate on the research. To achieve this and build a healthier future, we have to acknowledge our past and our present. And before I welcome Diane Longboat up to the stage, I want to reflect on Canada's past and unfortunately current treatment of Indigenous women. From forced sterilizations that inexplicably continue to this day, and birth alerts that disproportionately affect Indigenous women in Canada, that literally take away babies from their new mothers. This has to stop. We have to acknowledge it, and we have to do better. And with that, we're honored to welcome Diane Longboat here CAMH Elder, Senior Manager of Strategic Initiatives, who will share an opening invocation and message for women specifically. And Diane, I'm giving you a gift of ceremonial tabak. Thank you so much for being here.
Thank you so much. Sego Scano Seriguego, Nyawa Scano. My Mohawk name is Gahandagwas, and it means she's picking sweetgrass, one of our sacred medicines. And I'm Mohawk and Turtle Clan from the Grand River Territory, which is just south of here. I always like to say 2 hours because traffic is never kind to us. So I'm really grateful to be here with you today. And I want to say Nyawa to you, my beauties. You are extraordinary people. And I want to share with you, before I do the invocation, a bit of a message about how important you are in this time period. We as Indigenous peoples, Indigenous nations all the way across Turtle Island have prophecies about the time of the change in Mother Earth and how a very special generation of women would be born at that time. Two-spirit people, gender fluid people, men who would have all the gifts of the ancestors. And so today when I come and I spend a little bit of time with you, I want to share with you a ceremony that our people do. And that ceremony is very long. It could be 45 minutes. I'm going to give you the shortened version of it today. But that ceremony is important. And it's called the Ohodongoliwadekwa, the words that come before all others. Those are important words because they humble us. And we say in the face of the power of the universe, that source power, however you see that power to be in your faith tradition, in your culture, in your way of life. We humble ourselves and we ask for the power of the ancestors to wash over us so that we will have inspiration, a clear mind for innovation, that we will not be bound by walls or funding or legislation. I love saying that, legislation, or the things that human beings make that put us inside a box and say, you can only be this, you can only do this. And so today when we gather here as women and as men and as two-spirit people, we are gathering here for a very specific purpose, and that is to really focus on the health and well-being of women, and particularly in mental health. So we need all of our ingenuity, all of our energy to be able to work together. So these words humble us before our great creator, and they put us in relationship to the natural world and to all the beings, we would say, in the sky world. So those beings would be ancestors, your ancestors, my ancestors, and put us in relationship with spiritual beings in whatever faith tradition that you come from. So you can relax for a few minutes. You can close your eyes if you like. You can lean back. Please add some of your words to mine. It makes our invocation that much stronger. Nyawaskano, Sangwayadisam, Gahandagwas Yunyats. I give thanks this day, Creator, for the gift of life, that we have that chance to see one more day. We ask this day that you look upon us as a beautiful human family. So many faith traditions, cultures, languages, ways of being in the world that have made us so rich, so much to learn about one another, so much to appreciate about one another. We give thanks this day that you had a vision to create this place we now call our Mother Earth. And on that Mother Earth, you placed everything that we need as a human being to thrive. We live in abundance. And so we thank you for the great waters that are upon the earth, the fresh waters, the salt waters, the rain waters, and the birth waters. And we thank you for placing a grandmother spirit in each of those waters to watch over the sacredness of that water. We give thanks and honor today for all the plant life, the animal life, the bird life, all the living things that are in the waters of the earth, and how powerful it is to see how they all function together, how they hold hands and support each other mutually, and how we are also directed as human family to do the same with each other and with all the beings on the earth. So today we think about those thunder beings that are rolling across here, and we're so grateful that they've come to give us that medicine of rain, the lightning to ionize and clean the air. We're so grateful for the 4 grandfather winds that refresh the earth, and for all the stars that represent the ancestors. We thank you, Creator, for that very special star formation that we would say is the Milky Way, joining the natural world to the sky world. And on that journey of the Milky Way, new babies are coming into us today, and souls are departing to go to that place of peace where the ancestors have their fires burning. The ancestors are praying for us. They made a pathway for us, a legacy for us to follow. Male ancestors, female ancestors, 2 spirit ancestors suffered. They were sacrificing. They were challenged to be the best that they could be in their time and to create a pathway for us to walk today. So we want to make the ancestors happy with what they have given for us and what we can now give in this time period. And so we honor the ancestors today and all the spiritual beings that are the helpers of the Creator. We also honor them and we ask them to be with us in this room. Let them come into this room and open up our hearts, open up our minds to limitless possibilities of where we can go with our healing, with our research, with our relationships with one another that must be enduring. And so this day, Creator, we give thanks that you have given us this opportunity. You've made this day possible for us. Help us to do our best work today, to be bold, to be fearless, and to absolutely believe in ourselves that we have everything that we need to be successful. And so with these words, Creator, we give thanks for such a beautiful day, for the food we will have today, the water that we are drinking today, the medicines that we will consume today, and for the beautiful world that you have created for us in great abundance. Nyawa, miigwech. Thank you.
Good morning, everyone. My name is Sarah Downey, and I'm the president and CEO of CAMH. And I want to start by thanking Diane Longboat, who is an elder, so much in demand. I know I'm seeing her this afternoon with another group who's looking for wisdom and guidance as we build, as we move in truth and in partnership around reconciliation, which is a long journey. I want to start today by offering a land acknowledgement. This is CAMH's land acknowledgement, which was written by a group of staff who are part of our reconciliation working group. And I think it's very meaningful to me personally, and I'm pleased to be able to offer it. We acknowledge the land we situate ourselves on lands that have been occupied by First Nations for millennia. Lands rich in civilizations, with knowledge of medicine, architecture, technology, and extensive trade routes throughout the Americas. In 1860, the CAMH site on West Queen West appeared in the colonial records of the British Crown. It was the council grounds of the Mississaugas of the New Credit, as they were known at the time. Today, Toronto is covered by the Toronto Purchase Treaty number 13 of 1805 with the Mississaugas of the Credit. And Toronto is now home to a vast diversity of First Nations, Inuit, and Métis who enrich this city. My organization is committed to reconciliation. We will honor the land through programs and places that reflect and respect its heritage. We will embrace the healing traditions of the ancestors and weave them into our caring practices. We will create new relationships and partnerships with First Nations, Inuit, and Métis, and share the land and protect it for future generations. I had the chance to connect a bit with Diane today, but think about the damage to Indigenous women in particular. And we all know about the missing and murdered Indigenous women and girls and the impact of our terrible colonial history. But women in Indigenous cultures have positions of power and respect and authority with dedicated ceremonies. They choose the chiefs, actually, and they are the brains that operate in Indigenous communities. And it's a terrible impact of colonialization and patriarchy that's, I think, resulted in additional harm to Indigenous women. So I want us to hold that in our thoughts, and as we catch up on women's science and women's knowledge, to know that there's deep practices among Indigenous communities. So what a happy day this is for the people online, of course, and the people in this room, to have our first conference, the Women Mind Conference. We just launched a new strategic plan at CAMH, and it has 3 strategic directions, all of which relate to women. Thank goodness Lisa Galea and team have tons of energy to help us. And I just wanted to talk to you briefly about the 3 strategic directions. The first is to advance care with patients and families through learning and research. And unless we understand women, we can't deliver precision medicine, and Lisa just said it. The second is to get upstream to prevent and change the course of mental illness. And that's the idea that we now know and understand earlier warning signs of mental illness. If we could just get upstream, identify it sooner, put things in place, maybe we could avoid some of the long-term impacts of life with mental illness. We know, for instance, eating disorders in girls and how much that has increased as a result of this pandemic. And we've got to get our heads around getting upstream to support people better. And the third strategic direction is to lift societal health through action in mental health justice. And the women's movement is so powerful and speaks to the need to protect and advance groups that are disadvantaged in society, underappreciated in society. And I know in our hearts, and I know with the Women Mind movement, that it supercharges that strategic direction. The CAMH's Women Mind initiative was launched in 2020 as a community of philanthropists, thought leaders, and scientists dedicated to tackling gender inequities in science to put the unique needs and experiences of women at the forefront of mental health research. To date, Women Mind has funded 18 new projects focused on women's health. We have also recruited 2 superstar talents to CAMH, Doctors Daisy Singla, who I'm sure is here somewhere. I haven't seen Daisy yet this morning, and of course, Lisa Galea, who have dedicated their careers to the advancement of women's mental health across the lifespan. In addition, Women Mind has created a mentorship program for women scientists, where 50% of women scientists of CAMH have participated in the inaugural 2 cohorts. Most recently, we have celebrated a new partnership between Women Mind and the Women's Health Research Cluster, an international network of multidisciplinary professionals to promote, expand, and catalyze women's health research. This new alliance puts us one step closer to gender parity in science and putting the unique needs and experiences of women at the forefront of health research. We invite you to join over 570 cluster members across 29 countries by scanning the QR code on your table card to become a member for free. Before I turn the podium over to the next speaker, I'd like to take a moment now to offer my sincere congratulations to the Women Mind team for their dedication to building this incredible program over the past 4 years. Seeing you all in this room and in the virtual room is impactful, and we know the sky's the limit on what we can achieve together. Thank you. And it's now my great pleasure to introduce Sandy Treliving, a founding member and visionary of Women Mind and champion for women's mental health, to say a few words.
Wasn't sure if she was putting me later there or click on later. Thank you, Sarah. As Sarah mentioned, my name is Sandy Treliving. I am a proud member of the CAMH Foundation and so excited to be here for our first conference, Advancing Research in Women's Mental Health. This was but a dream in March of 2020 as we began our new journey building womenmind. The Treliving family are the founding funders of CAMH womenmind, and it is my honor to put the it is my honor on behalf of the womenmind community to welcome everyone participating in person and virtually. Womenmind is a unique community. I'm so sorry, my allergies are kicking in. Womenmind is a unique community dedicated to tackling gender disparities in science to put the unique needs and experiences of women at the forefront of mental health research. Philanthropy has enabled us to build this vibrant and growing womenmind community and fund critical research that is already improving the lives of women around the world. Which is why I'm standing before you now and why my family helped launch this community. I'm very excited to witness and be in a room filled with individuals that want and have the same goal to close the gender gap for women's mental health and put a spotlight on women and girls. Every single one of you in the room is helping to reach that goal unitedly and globally. This conference is a celebration of how far we have come. When you think about a healthier sister, mother, daughter, a healthier Canada and world can mean, the benefits of womenmind are limitless and far-reaching, economically, social, environmentally, politically, and beyond. We know that women's mental health has been underfunded, understudied, and undervalued for decades. We are working to change this, and I have confidence that the next 2 days will provide a small glimpse into what impact, collaboration, sharing, and insight can have for women. I want to wish you the very best, and I look forward to learning from you all. A quick pitch, if you are not a womenmind member now, please join us today. I'd like to welcome Dr. Aristotle Boyneskis, Vice President of Research at CAMH, to talk about the impact of womenmind and the importance of women in research at CAMH. Thank you all.
Hi, everyone. So we had a number of amazing women and one more to come deliver their remarks. I'm going to try and keep mine brief. My first introduction to women's mental health research was really one of my first days as an undergraduate student meeting Dr. Mary Seaman. And I just want to acknowledge how important she was in my career and I think to this entire concept. She did, for those of you who don't know, she was someone who did research to understand the experiences of women who suffered from schizophrenia and was probably the top international person in that regard. So I just wanted to acknowledge her legacy today. And then, of course, womenmind, which is the, Deborah Gillis and Sandy Treliving who really led the way. It's a fundraising tactic, as you've heard, to support women in science and women's mental health. And it was brilliant. And I would say the hospital embraced the idea immediately. I'd also like to acknowledge Dr. Sam Wells and Vicky Sturgiopoulos for the initial leads of this initiative on the hospital side, and Drs. Haley Hamilton and Isabel Boileau, who co-led the development of the mentorship program, another key part of womenmind, and the many people who've co-chaired the committees to review the grants, review the trainee awards, And when you invest money somewhere, it attracts a lot of people to do that kind of science. So this group is growing and growing and growing and leaving a bigger and bigger footprint at CAMH and around the world. Really in my first week on this job, which was about 3.5 years ago, I remember diving right into helping complete the recruitment of Dr. Daisy Singla, our first true living scientist, which is really a fantastic achievement for all of us. And Daisy's just flourished at CAMH and her team's growing and she's doing amazing research. And then it was such a delight sometime after to recruit Dr. Lisa Galea from UBC to become the inaugural True Living Chair in Women's Mental Health. As you know, you don't need me to tell you this, Lisa's boundless energy, visionary ideas, and is always at the ready to teach me a critical fact or two about women in science for women's mental health. And that's Lisa. And it's my job, and I would say the entire executive leadership team's job at CAMH to help Lisa and everyone committed to this cause achieve their dreams and to further women's mental health research. There's an elegance to the simplicity of womenmind, in my opinion. It's simple in its concept, but I think fantastic. It really supports women in science all the way up into leadership positions, as well as to support women's mental health, to grow our knowledge where there's critical health disparities for women, and to commit to addressing those disparities through impactful science, education, and clinical care. It's amazing to see these 2 days unfold. I think it's going to be a fantastic couple days. It's the culmination of the work of so many people, sold out event, as Lisa mentioned, and it's putting CAMH at the forefront of women's mental health, and with a women's health research cluster, even women's health, so watch out. And it's a privilege to introduce this day and an even greater privilege to hand it over to Lisa now, and just want to wish you all a fantastic 2 days. Thank you.
Issues. That's a good idea. Well, thank you so much for those opening remarks and reflections. I really appreciate the amazing words of Diane Longboat and thinking about our ancestors and how she was trying to calm my nerves in the room before and say, think about your ancestors and how they've opened the door for you. And I do acknowledge my amazing ancestors who have led me to where I am today. So before we start into the scientific program, I want to emphasize why women's mental health research matters. You're going to hear over the course of the conference many mental health disparities between women and men, but I really want to make it abundantly clear that all of the disparities that we're talking about between men and women, boys and girls, are many-fold greater in Indigenous peoples, people of color, gender diverse, sexual and gender minorities. And you're going to hear from some experts on those topics. Each of those communities deserves acknowledgement and research specifically in those areas because their experiences, their health outcomes, their disease risks are going to be different than what we see just between men and women. So it's just really important that we acknowledge that. Women's mental health research and solutions require a deep dive into female-specific experiences, and that's partly why we're here today. Things like pregnancy, hormonal contraceptives, menopause, and we have a symposium on each and every one of these topics. And as you're going to hear, women's mental health is not just about one thing. I don't want to steal thunder, but Jillian Einstein taught me there are many menopauses. It's not just one thing. Just like there are many types of hormonal contraceptives, and they don't all, unlike what the CEO of X says, they don't all have the same influences. And we'll have a symposium next week on next week. I would like to have a week-long conference, but tomorrow on that. And I think sometimes we do ourselves a little bit of a disservice when we talk about like, oh, hormones are good or hormones are bad. Inger has a really fantastic paper called Progesterone Friend or Foe. And I always just really appreciate the title of that. Because sometimes estrogens and progesterones help, and sometimes they don't not necessarily help. Allopregnanolone might help in certain situations, might not in other situations, and that's what we're here to learn about over the course of these few days. We're going to hear also from experts that do a deep dive into sex and gender-related variables and how they influence mental health. So we're going to hear from Dr. Sene and Dr. Hodes about how solutions to major depressive disorder require this kind of detailed sex-specific analysis because there are different pathways that are expressed with these different disorders. You're going to hear from Dr. Damala. I'm trying to find people as I look across the room, but and she's done some really fantastic work looking at how if you've heard of probably AI, machine learning, if you base your predictions on male-only data versus female-only data, and then try to see if those prediction models are the same or not using data sets, and it's really fantastic work that she's been doing. We intentionally plan these symposia to have preclinical and clinical researchers in each one of them. This was by design, because I'm sure you've probably heard the idea that there's a lack of translation from animal to clinical trials, and there's a lack of what am I trying to say here? There's a lack of progression of clinical trials, so we see a lot of failure in them. I firmly believe that failure is because we don't pay enough attention to sex and gender based on variables. We don't pay enough attention to pregnancy history, hormonal contraceptive use, menopause therapy, hormone therapy. And yes, right? That deserves a clap, I think. And if we, yeah, you don't have to. Yeah, it's pretty frightening out there, actually. If you try to look at some of these databases, you don't always see those kinds of variables reflected in those databases. And so that's why it's so important to pay attention to them. So if we build good models of disease from both a preclinical and clinical perspective, we're going to get there, and we're going to improve health for all of us. So sex, gender, and women's health variables are going to get us a long way towards personalized medicine approaches, yet are rarely examined. I could give you stats, but it's not me that's up here today. It's the rest of you. So I want you to join us on this 2-day journey to explore the power of harnessing the heterogeneity of women's health variables, sex and gender, to improve mental health outcomes. Before we really start, a few housekeeping details. Restrooms are located outside of this room, just past the elevators. I'm also been told to just, if you are, feeling achy, just get up and move around. Nobody's going to be upset about that. There are fire exits, which are located in the main hallway to the right and near the washrooms. All the information you need is accessible on a QR code that's on your table. We also have 48-ish posters from trainees across 2 days. You get to vote on your favorite. For the online community, you'll be able to view them, but not vote on them. I'm sorry about that. We'll fix that for the next time. But at least you'll be able to view those posters. And I'm sure people will be happy to answer questions if you email them about them. And I need to extend a great thank you to our team that made this event possible. Thank you to Jenna Roy. Okay, Tiara, I always just call you Tiara. I don't know how to pronounce your last name, but Hone, Tiara Hone, who's over there. And Bonnie Lee, who is has the fortune and unfortunate, there she is, a characteristic of also being one of my senior PhD students who almost has her publication, her next first author publication accepted. We're just dealing with one persnickety reviewer. It's okay. I also want to thank the working group for their dedication and support over the past 6 months, and a special thank you to all the volunteers. We have a lot of them here. I'm going to make you put up your hands because some of them are in my lab, and so therefore you get but not all of them are in my lab. The one person that's not in my lab, but please put up your hands so that people know they can ask you questions. So don't be shy. There you go. And some of them are going to be here to remind us to keep time, which I think I'm over time, so I got to start. Let's keep the conversation alive on social media. So please use the hashtag womenmind, hashtag womenmind24. Also, please be respectful. We're all learning from each other. I learned at a conference a year or so ago that there are no separate words in languages like Swedish. I don't know if this is true, you guys tell me. German's probably different because German has a word for everything, including grief, bacon. No? For sex and gender, do you have different words for sex and gender? No? No. Okay, so that you have a word for grief bacon, which is what we eat when we're, feeling bad, but they don't have separate words for sex and gender. So, there's a lot of conflation in the literature on sex and gender. Maybe it's because of language. It's not just Swedish, Danish, German, it's, I think, Japanese and Mandarin as well as many other languages. So I think we just need to be mindful of that. So thank you very much for being here online and in person. I hope you're going to see the importance of valuing and protecting this community so we can all contribute to the broader vision of advancing women's mental health, because honestly, we're stronger together and we should be lifting each other up, which I know we do. All right, so without further ado, I'm going to present our first. You have the unfortunate of having me as a moderator for the first session today. And we actually have our first speaker who will come up. I don't know how to put her slides up. Do I know how to do that? Shall we do it? Shall I ramble while somebody puts her slides up and she comes to the stage? Yes, what? Oh. Me to be closer to the mic because it's hard to hear back there. I think you guys can hear me. You guys, is it hard to hear over there? Well, that's no good because I said brilliant things. Okay, so all the speakers that come up, but then they don't want to hunch over. Is it just me? It could just be me. It's not just me? Okay. So just try to get a little closer to the mic while we fix the audio. And while I'm yammering on, Dr. Nafissa Ismail is going to come up. Our first session is called Understanding How Hormonal Cycles Impact Mental Health. And I'm pleased to invite Dr. Nafissa Ismail, who I've known for quite a while. She's from the University of Ottawa, to kick us off. Thank you, Nafissa.
Sorry about that.
Well, hello, everyone. Thank you very much for this kind introduction, Dr. Galia, and thank you very much to CAMH and the entire organizing committee for inviting me to come here and get to share my work with you. It's truly an honor to be here. And I'm going to talk to you about our work examining the link between pubertal stress, hormonal changes, and mental illness. Yeah, I'm just trying to change my slide. So I'm not saying anything new today by telling you that depression can affect anyone. It is one of the most widespread illnesses, often coexisting with other serious illnesses. And it has become now the leading cause of disease burden worldwide. Now, this is coming to us a little bit early because in a report published by the World Health Organization in 2019, they predicted that depression would become the leading burden of global disease, but only in 2030. So this has come to us a few years early, and let's just say that the COVID-19 pandemic was an important contributor in speeding that up. So it's really important that we make rapid and substantial progress in understanding the pathophysiology of depression so that we can come up with effective treatments for all. We know, though, that there is a considerable lack of knowledge around the pathophysiology of depression. We know some, for instance, we know that it's associated with a dysfunction in monoamine neurotransmission. This has been studied most widely, and the current pharmacological treatments that we have against depression concentrate on normalizing monoamines like serotonin, norepinephrine, etc. But then we also know that these treatments are not effective in all cases, suggesting that there is more to the story of depression than simply a dysfunction in monoamine neurotransmission. For example, we know that exposure to certain stressful life experiences can induce depression. And here I'm referring to stressful life experiences that are not only going to activate our stress system, but also our immune system, cause inflammation, neuroinflammation within our brain, and that are enduring and out of our control. And examples of that are psychosocial stressors, abuse, etc. We also know that many cases of depression and also anxiety start during puberty and adolescence with a mean age of onset of 14 years old. So it starts quite young. And we also know that as of puberty, females become 2 times more susceptible to developing mood disorders like depression. So in my lab, we want to identify those stressful life experiences that can induce depression, and we want to understand why females become 2 times more susceptible to developing depression once they reach puberty. And where is this susceptibility to stress and immune activation and how that can induce mental disorders? For one, we know that there are important sex differences in immune response to both self and foreign antigens. For instance, we see that females are more susceptible to certain infectious diseases and autoimmune diseases, whereas males are more susceptible to other infectious diseases as well as non-reproductive cancer. Now, this sex difference is not the same throughout the lifespan. It also changes with age. So we see that after puberty, females mount a stronger innate and adaptive immune response when there is stress or exposure to a pathogen. But prior to puberty, it's the males that mount a stronger innate and immune response. So yes, a lot of work has been done examining these sex differences after puberty and prior to puberty. But what about puberty? We don't know much about how the stress and the immune system change during puberty and what sex differences look like during this period. And it's really important because puberty is a critical period of development. It starts once our hypothalamic pituitary gonadal axis becomes active and stimulates our gonads to produce and release gonadal steroid hormones. And these gonadal steroid hormones are then going to drive various changes in our brain, in our body. They will lead to sex-specific maturation of the reproductive system, sex-dependent development of the brain, behavior, and physiology. But when we are exposed to a stressor that will activate both our HPA axis, our stress axis, and our immune system, we see an inhibition of this axis. So the HPG axis, or hypothalamic pituitary gonadal axis, becomes inhibited, and we're now suppressing the production of our endogenous hormones that are supposed to guide all these changes in our body during puberty and adolescence. And this may be a link to onset of mental illness during this critical period. We see that as many as 49.5% of adolescents have had a mental disorder at some point in their life. We also see that adolescents with mental disorders have a decrease in life expectancy by 10 to 15 years compared to the general population. So clearly, there is a link between stress and inflammation, hormones during puberty, and mental health. And in my lab, we want to understand this bi-directional circle between these factors and see what we can do to prevent mental illness during puberty and adolescence, and particularly in our female population. So as a stressor, we use lipopolysaccharide that you will see abbreviated as LPS, and it's a bacterial endotoxin that will bind to toll-like receptor cells on the surface of immune cells and activate an intracellular cascade that will then lead to the production and release of cytokines, causing inflammation, an activation of the immune system, but also an activation of the stress system. So it mimics those enduring stressors that as humans we are exposed to. And what's also really interesting is that in addition to causing inflammation in the body, LPS will also, like the stressors that humans are exposed to, induce neuroinflammation. And it will do so by either stimulating the novosynthesis of cytokines within the brain, or it will increase the permeability of the blood-brain barrier and allow toxins and inflammatory biomarkers from the body to enter the brain. And so we wanted to use this model and examine whether we can induce depression in a mouse model. And the reason why we chose the mouse as a model is because the mouse pubertal period is very similar to that of humans, and we undergo very similar hormonal changes as well. And if we wanted to examine the brain, we needed an animal model that would allow us to do that. So we had mice shipped to our lab at 3 weeks of age, just as they were being weaned. And that has been shown to be a stress-resistant period. And then we let them acclimate. And at 6 weeks of age, when they reached the pubertal stress-sensitive period, we injected our mice either with lipopolysaccharide or with saline. Then we let them reach adulthood, and at 10 weeks of age, we began behavior testing to examine behaviors that are similar to depression-like behavior. So before I show you the data on the behavior test, I'm going to show you some of the data that we found more acutely when the LPS was being administered. And for one, what we found were important sex differences in the acute effects of LPS treatment, such that when we gave LPS to our animals, the males showed more sickness behavior, greater hypothermic response, more serum concentration in the blood, as well as more activated microglial cells in the brain. Females, on the other hand, showed greater serum corticosterone concentration. So females are mounting more of a stress response, and it looks like the males are mounting more of an immune response. And in some ways, their immune system seems to be hypo-responsive to our stressor. We also found age differences. So the adults, compared to the pubertal animals, displayed more sickness behavior, greater fluctuations in body temperature, more serum cytokine and corticosterone concentration, suggesting that in general, the pubertal animals seem to be hypo-responsive to the stressor compared to when it is administered in adulthood. And it makes sense because the stress system and the immune system are still developing and maturing at that age. And when stress arrives, they don't know how to handle it. And it may be the reason why then they're not able to bring the system back to homeostasis, and that may lead to the enduring changes that we observe following stress exposure. And we found very interesting enduring effects when LPS is administered during puberty at 6 weeks of age that we didn't see in our mice that received LPS in adulthood. So we found decreased sexual receptivity in our female mice. We also saw impairment in spatial learning and memory in the females, as well as increased depression-like behavior. Whereas in the males, we noted decreased dopamine-sensitive behaviors, as well as increased anxiety-like behavior. So I'm going to spend some time talking to you about our data on the depression-like behavior. To examine depression-like behavior in mice, we use the forced swim test, which is a validated test that is commonly used in the literature. And it consists in placing the mice in a beaker filled with room temperature water. And mice know how to swim, so they will swim in that beaker, but they don't like to swim. So eventually they give up and they become immobile, at which point they just float at the surface of the water. And it's that immobility that we quantify, that giving up and saying, I don't want to swim anymore. I don't want to put effort anymore, because that duration of immobility is said to be indicative of the symptom of depression, that is behavioral despair. So the greater immobility, the greater behavioral despair we would expect. And so when we examined immobility in our mice, we saw that the mice that were treated with LPS during puberty displayed increased the duration of immobility, so increased depression-like behavior, but only in females. We didn't see that in the males. So that was really interesting. So we saw that LPS during puberty induces that depression-like phenotype in the female mice, but not in the male mice. And we were really excited to find that model, that mouse model that allowed us to see this sex difference that we see in humans. But we wanted to understand this mechanism and try to see what is happening and why are females here showing the depression-like phenotype with LPS and the males are not. And we thought of looking in the gut. The gut, we know, is composed of numerous microorganisms, and it connects with the brain through the gut-brain axis. And there is a bidirectional communication between the gut and the brain. And the microorganisms in our gut can impact brain function, and vice versa. The brain can impact the type of bacteria that we find in our gut. And we wondered, because there are sex differences in the bacteria that we find in the gut, there are age differences in the bacteria that we find in the gut, could stress be impacting the brain through the gut microbiota? And so if that is the case, then colonizing the gut with good bacteria could help us prevent then stress-induced mental illness. And so to examine this question, we partnered with Liosan, a family-based Quebec company. They produce various probiotic products that are sold under the brand Yo Gourmet. And we were supported by an NSERC Engage grant for this work. And so what we did is that we again had the mice arrive to us at 3 weeks of age as they were being weaned. We let them acclimate. At 6 weeks of age, they also received either saline or LPS treatment. But 1 week prior to the LPS treatment, we began a 2-week course of probiotic treatment. So for 2 weeks, they received either the kefir probiotic or just skim milk. And at 10 weeks of age, we examined their behavior. And we were surprised and very happy to see that the pubertal females that received the kefir probiotic during puberty, just a 2-week course, prevented the stress-induced depression-like behavior. So we saw no difference in the duration of immobility between our LPS-treated females and saline controls if they had received that 2-week course of probiotic treatment. So what is happening in the gut? How is the gut contributing to mitigating the effects of stress during puberty? Well, when we look in the gut, we see that LPS is causing lots of age and sex differences in various genera of bacteria. The heat map on your left side is depicting the sex differences. The diagram here on the left side is depicting the age differences. But we're not experts in all these genera, and so we went a bit higher up in the taxonomic hierarchy, and we examined things at the level of the phylum. And some of the differences we noted are that when the male mice are treated with our stressor, we observed a decrease in Firmicutes and an increase in Bacteroidetes. Firmicutes is typically quite abundant in the mouse and the human gut, and it's involved in energy reabsorption. But given that the animals are losing weight following the LPS treatment, it makes sense to see a decrease in Firmicutes. We also see an increase in proteobacteria, which is important in energy metabolism and increased inflammation. However, when kefir is on board, then we see that LPS no longer increases proteobacteria, which is associated with inflammation, but rather will increase verichromicrobia, which is a phylum that we typically find in low concentration in the gut in humans and mice. But when antibiotics are on board, then we do see an increase in this phylum, perhaps suggesting enhanced immune function. So maybe the probiotics are enhancing immune activity. In the females, the story was slightly different, where we found that LPS treatment again decreased Firmicutes, but this time increased Bacteroidetes. And Bacteroidetes is a phylum that is associated with malnutrition, weight loss, And we do see that our females lose significant amount of weight when they are administered the LPS treatment. But when kefir is on board, we don't see that significant weight loss, nor do we see a decrease in firmicutes or an increase in bacteroidetes. So it's really nice to see that the probiotics are able to prevent these enduring changes in the gut. So what's the mechanism? Well, we think that it's an issue of a leaky gut leading to a leaky blood-brain barrier and allowing toxin from the periphery to enter the brain. As John Cryan says so well, you might have heard of the saying that what happens in Vegas stays in Vegas, but our data shows that that is incorrect. What happens in the vagus nerves gets to the brain and causes neuroinflammation and could lead to mental illness. And we did test that. We found that indeed there is increased permeability of the blood-brain barrier, and it shows earlier in the females. We see it at 24 hours following the LPS treatment. We see it in the males as well, but it appears a little bit later. We saw it at the 1 week time point. And so if we go back to our final model, yes, indeed, there is this bidirectional interaction between stress and inflammation, hormones during puberty, and mental health. But to that, I would also like to add another factor, which is the gut microbiome. To conclude, our work shows that there are important age and sex differences in the acute response to an immune challenge. Exposure to pubertal immune challenge causes enduring sex-specific changes in behavior, and in the females, we saw that it induces depression-like behavior. And we do see that there seems to be a transient effect of LPS on the gut microbiome, on the blood-brain barrier. But we were very happy to see that probiotic treatment during puberty seems to mitigate those effects of stress on the brain and on mental health. Now, of course, there is a lot of work left to do to understand the mechanisms and how stress is being prevented by altering, the effects of stress is being prevented on the brain by altering the gut microbiome. But we hope that eventually our work will help us understand the risk factors for mental disorders during puberty and also hopefully provide potential preventative measures. So with that, I'd like to thank my graduate students, the numerous undergraduates and international visiting students that contribute to our work, and CERC for funding our research, the MICE for their contribution, and you for your time. Thank you.
Is that better? Okay. There was a sentence about that changes weren't long lasting. I don't know if you covered that, but
yeah. Oh yeah. Thank you for reminding me that. So yeah, we found these effects in the gut, these altered effects about up to 48 hours after the LPS treatment. When we examined at the 1 week time point, there was no more difference in the gut microbiome. So it's a good news that the gut is recovering, but it also shows that a very short window of alteration in the microbiome is sufficient to impact the brain and the behavior. So that aspect is also a little bit worrisome. At what point exactly the gut recovers from the stressor, we don't know, but we just know that as of 1 week, the 1 week time point, they have fully recovered.
Wait, I don't know if I missed it, but also
Hi, whoa, I'm sorry. I don't know if I missed it, but did you also look at these models in aged mice or just the puberty mice?
Yeah, so we administered our LPS treatment. Most of our work has concentrated on the pubertal animals. So we did inject the LPS during puberty. But in our earlier work, we kept comparing to giving LPS in adulthood as well, just to see if the effects are limited to pubertal animals or they also extend to adulthood. And we noted that there was no enduring change in the behavior when LPS is administered in adulthood, but only when it was administered during puberty at 6 weeks of age. Thank you. Thank you so much.
And, no, it's not up. Did I do the wrong thing? Thank you to Nafissa. I can't resist saying this one little joke, which I know we're gonna bring back, but I think her first explanation there was a good example of the man flu. I don't know if you got that, the inflammation response. It's now my pleasure to introduce Dr. Marija Kundakovic. Every time she speaks, she blows my mind, and I know my new neurons grow and grow and grow. She's from Fordham University, and without further ado, I welcome her to the stage.
I'll just have this with me because I heard that the air is dry in Toronto, so, and I kind of feel a little allergies here, so hopefully. Okay, let me just point. This should work. Everyone can see this, right? Okay, perfect. So first of all, thank you very much for this great opportunity. It's really an honor, and thank you to Lisa. Thank you for the donors. Thank you to all the organizers. It's been really like a dream symposium for me to talk about ovarian hormones and mental health, because that's something that really I feel very strongly about. But I studied the molecular basis of this. As you will see, I'm going to talk about the brain and genome. But I wanted to start really with this, what really inspired me to start doing this work. So I was teaching at Columbia University. I was teaching this class on neuropsychopharmacology, and I wanted to prepare the lecture on the sex in the brain. And I knew forever that like women are at twice higher risk for depression than men are. But somehow I didn't really know that this is really only during the reproductive period. And so when I saw this graph that I'm showing to you, it was like, I was stunned, literally. It was like a revelation for me. So what you can see is like in the upper panel is the depression risk in women and men. And then here you can see how hormonal levels change throughout the lifespan of women, right? So you see pre-puberty, boys and girls are really very similar in terms of their risk for depression. Actually, boys may have a little higher risk. And then this risk jumps to 2 times higher in women when actually girls really start menstruating, when you start seeing these fluctuations in hormones, right? And then throughout this reproductive period, you have these two times higher risk in women that correspond to these cyclical changes. And I like this symposium because it's called hormonal cycles, right? It's about cyclical changes. Then please note this further jump in risk during the perimenopause when you have this most extreme hormonal fluctuation, right? And I'm going to come to this at the end of the talk. And then once you have this postmenopausal period, the risk in women and men becomes very similar. So the first point here is really not about high or low estradiol, as Liz already said, but it's really about these fluctuations in hormone that somehow seems to increase the risk. And also we have these other conditions such as postpartum depression, right? When you have this sudden drop in hormones, when 20% of the people that actually give birth would develop postpartum depression. We have premenstrual dysphoric disorder that affects 5 to 8% of people. And then there's this really interesting phenomenon. It's called the premenstrual exacerbation, which means that in up to 50% of people with mood disorder, the symptoms actually are becoming worse premenstrually. And no one actually tells you anything about this, I guess. But we know actually in this room that ovarian hormone fluctuation is a major psychiatric risk factor, right? Although the mainstream psychiatry doesn't really talk about this because it's a female-specific factor, right, unfortunately. But I'm a molecular neurobiologist, and I would like really to understand the molecular basis of this so that we can actually really think about drugs, new drugs that actually can be completely different in a way. So why is this really even important for mental disorders? Because estrogen is really, or all ovarian hormones are really not only reproductive hormones, they are very potent neuromodulators. And Nafissa already mentioned the monoaminergic system. I'm showing here that estrogen can actually enhance both serotonergic system and noradrenergic system. And I'm emphasizing them because the current anxiolytics and antidepressant drugs are working on these systems. And estrogen can also increase BDNF mRNA levels. So this is all in line with the antidepressant-like activity. So people can ask you, okay, so if estradiol is antidepressant-like compound, why would women be at higher risk? And again, we are coming back to these fluctuations. It's not about estradiol, it's about these withdrawals of drops in estrogen we are experiencing. They may increase depression or anxiety risk because this requires a periodic neurochemical adaptations, right? So how do we study this? Ideally, you should study this in humans, and I'm going to show you at the end some studies in humans. But we actually study this in mice because we want to do like more mechanistical studies. And so mice and humans are really similar in terms of this hormonal cycle, right? So if you think about menstruating individuals, and I do want to say here, I want to be inclusive that what we study is really not only for women, it's really for all people that menstruate. This can be cis women, this can be non-binary people, and it can be even transgender men who menstruate, right? So in humans, you have this follicular phase when you have high estradiol and low progesterone. And in mice, we have something that is called proestrus, when you have also high estradiol and low progesterone. And then luteal phase in humans, when you have a low estradiol and high progesterone, is actually more similar to this early diestrus that we focus on, that has a very similar profile. So how we study this, we actually take these vaginal smears daily in our mice, and then for at least 3 consecutive cycles, and then we can actually put them into this high estrogenic or low estrogenic phase, and we actually double check the hormonal levels, and they do indeed actually correspond to what I just explained. So I typically am going to show you the data on these low and high estrogenic females, and then males. They're all 3 weeks old, so they are like young adults. And then I'm going to show you some data on the over-optimized animals, because sometimes we want to remove ovaries and try to kind of rescue the phenotype, right? So we started with behaviors, and these are very simple behaviors, but I think they're really relevant for humans just because there is this pattern that I'm going to explain that is very similar in mice and humans. So rodents typically would spend more time around the corners, in the dark areas, in the closed areas. But if you give them anxiolytic compounds, they will actually spend more time in the center, in the lit areas, and then in the open or elevated areas. So that means that they are less anxious, right? So what we were able to show, and for me, this was really stunning because this was the data that we created in my lab, is that when you have a high estrogenic female, they're more similar to males. Whenever there is a drop in estrogen, this is when we see actually increase in anxiety needs. And again, this is translationally relevant because you see this premenstrual in humans and stuff. I also want to tell one important thing here. If you put together these 2 female groups, compare them to male, there are no sex differences. So you completely lose this clinical relevance of hormones, right? So it's important. So then we were interested, like, what is driving those changes in behavior, right? And we really decided, of course, you can study a lot of different brain regions, but we decided to focus on this ventral hippocampus. And the reason why we focused on this is because there were studies like for decades that show if you for instance, lesion this part, or you optogenetically activate this area, you will specifically change anxiety-related behavior, but not memory, right? And as I will tell you in a second later on, there is a very nice, it's very conserved. So there is a very similarity between ventral hippocampus in mice and anterior hippocampus in humans, right? So, and we were actually able to show that as you are changing through the cycle, there is a change in brain structure as well. So we looked at this dendritic spine. These dendritic spines are these little intrusions in the dendrites of neurons that actually are important for learning and memory and synaptic plasticity. So what you can see when you have high estrogen, you see this increase in dendritic spines, and 24 hours later, you see drop in this. So this is what I think is a structural basis, basically, for what we see in terms of behavior. So now, but as I told you, I'm a molecular neurobiologist, so I want to understand the mechanism for this. And this is where we need to study, because we need to understand how do we design new drugs, right? Because we need some targets, right? So when you think about estradiol can act either through these nuclear receptors, which estradiol would get in, bind to this receptor, bind to the DNA elements in our genome, and this can change in expression. Or estradiol can also bind to these membrane-bound receptors, activate certain kinase pathways and other transcription factors, and also change gene expression indirectly. And because we know that in our ventral hippocampal neurons, you have both nuclear and membrane receptor, we knew that they both could be possible targets, right? But my expertise is actually in what we call epigenetic regulation of chromatin. So this is why I was thinking, maybe this is the case, we should actually look there. And so I have to say also, when we started this, like, there was also there were studies showing that estradiol can change the chromatin and epigenome in cancer cell lines, but no one really knew anything about the neurons. So This was kind of a little tricky and risky, but I'm glad actually we started it. So this is like what the chromatin is. It's like, DNA in our cell is not naked. It's actually wrapped, this is a highly organized structure where DNA is wrapped around these histone proteins. And what really is important here is that this is not only important for the packaging because you need to actually put this really long DNA into this small nucleus, but by opening and closing this structure, what you happen is that you open the opportunity for transcription factor to bind so that when you have open structure, you can express genes. When the structure is closed, then genes cannot be expressed, right? So my idea was like, because I was a epigeneticist, maybe as you are seeing these changes in hormones, right? In the post-mitotic neurons, in the ventral hippocampus, you may actually see opening and closing of this chromatin that can actually lead to changes in gene expression and explain our changes in behavior and structure that we are seeing. So we did the two types of assays to show this, and I'm not going to go into the detail, but the ATAC-seq is the assay that show you which regions are open in chromatin throughout the genome. And then RNA-seq is actually showing you which genes are being changed in terms of their expression. So when we started looking, it was really, for me, amazing, like how many changes we found, right? Because the first thing that I wanted to do was like, we are going to do the physiological cycle, right? And people were like, you're never going to see any changes because you just have to do overoctomy and give estradiol. But we decided to do the actual cycles. So what we found really that throughout the cycle, at least there are 30% of regions that are changing chromatin organization. So you have opening and closing of chromatin, around 30% of the genome changes across the cycle. And this degree of change is actually very similar when you compare two female groups and then you compare males and females. So it was also remarkable. What is also important is actually affect the genes that are important for neuronal function. So for instance, if you take these regions and do this bioinformatics analysis, you see that this is like a genes that are important for synaptic transmission and other things. Just to give you an example, this is a gene that actually encodes for glutamate receptor. So during high estrogenic phase, sorry, it stopped. I don't know what's happening, but it stopped. Someone raised hand, maybe that's.
You should just be able to click through. Oh. Microsoft PowerPoint is not responding, but it looks like it's responding again now.
I am not. Okay, good, great. Okay, let me see. Okay, sorry about it. Okay, so if we look at the, this is the gene that is actually important for the glutamate receptor. So during high estrogenic phase, no. No. Okay, so during the high estrogenic phase, you have this more open chromatin, right? And then during the low estrogenic phase, this is when you have this closing of the chromatin, right? And this is actually also associated with changes in gene expression, right? So it actually tells us that these changes in chromatin are actually happening in the genes that are important for neuronal function, and that they are actually functionally relevant. So we also looked and we found that there are serotonergic genes that are changing. And this is now important because, as I told you, estrogen can change serotonergic function, but this is now the first time that we have a molecular mechanism that actually are showing how estradiol can change. So just to give you an example, this is the gene that actually encodes one of the serotonergic receptors. So you have more open chromatin when the estrogen is low, and then this is closing when the estrogen is high. And this actually corresponds to the changes in gene expression. So we also looked at how many genes are actually changing expression across the cycle. And we found that up to 200 genes are changing expression across the cycle. At least 50% of them are actually also changing chromatin, which means that these chromatin changes are really important for changes in gene expression. And when you look at these genes, there are genes that actually are important for sphere response, hormone-mediated signaling. But there was something that we really did not expect. That there are also genes that are regulating chromatin remodeling. And so these are telling us that not only chromatin organization changes across the cycle, but the expression of genes that regulate chromatin also changes. So which actually led us to this conclusion that chromatin regulation is really important to how hormones are regulating neuronal function. So now with using this data, we can also ask the question, is estradiol actually acting through this nuclear or the membrane bound receptor? And this is how we actually ask this question, is actually we look at this, everything that is open during the high estrogenic phase, and then we do the motif analysis and ask, do we have the enrichment of estrogen response element or do you have the enrichment of something else? So when we looked, we took all of these genes, or actually chromatin regions that are open only during the high estrogenic phase, and then we did motif analysis, and we did not find any estrogen response element, but we found the EGR1. Why was EGR1 important? So EGR1 is one of these immediate early genes, and there were like actual studies that showed that immediate early gene products can actually open chromatin in neurons. So what is also important for us that EGR1 is not only the binding site for it that is opening up during high estrogenic phase, but there is also induction of EGR1 during the high estrogenic phase. So that means that it's an estrogen responsive immediate early gene that is candidate chromatin regulator. So what we actually were thinking, so now should we try, instead of like doing something that typically people do the overoctomy and replace with the estradiol, instead we can actually try to overexpress EGR1 and try to model high estrogenic phase to actually find that these changes are really functionally important for changes in behavior. So what Devin, my graduate student, did, he actually took like, these EGR1 vector viruses. So what you can do is actually you inject those viruses into the ventral hippocampus and you overexpress EGR1. And so we actually made sure that it's specifically overexpressed in the ventral hippocampus and not in the dorsal hippocampus. And the overexpression was around 10 times, right? So it was not something crazy, but it wasn't really also physiological. And then we looked at behavior, gene expression, chromatin, and dendritic spine density. So what was really amazing to us, like, when you take over-optimized females and then you actually inject them and overexpress EGR1, you're actually able to mimic the high estrogenic phase of the cycle, right? Just over-optimize the animals without giving estradiol, just overexpressing EGR1, you make them less anxious. However, you do that in females, but not in males. Then what we did, we also took these female mice and then overexpressed EGR1, but then we look at the gene expression. And we were able to recreate 20% of changes that we are seeing in the estro cycle. So just to show you how this looks, for instance, I show you this gene already, it changes both chromatin and gene expression across the cycle. And then what will happen if you do overexpression of EGR1 in these over-optimized animals, you actually are modeling the proestrus. Then we also look at the chromatin data, and after EGR1 overexpression, we did a toxic and chromatin analysis. We were actually able to show what we were expecting, that when you overexpress EGR1, you open chromatin, and specifically in EGR1 binding site, but it is specific for females, right? So if you look at the females, you overexpress EGR1, you open chromatin in females, but not in males. And finally, when we overexpress EGR1, we were also able to show that there is increase in the dendritic spine density in female that we also see during the high estrogenic phase of the cycle. And then this is not happening in males. So, sorry, this is happening in male, but it's a lower effect site. So what I showed you so far is basically that we can mimic the estradiol by overexpressing EGR1. So we see changes in behavior, brain structure, gene expression, and chromatin organization. And all of these changes are sex-specific and proestrus-like. So this is also like a proof of concept that we can actually use genomics data from this physiological model and get and modulate certain factor that actually driving these estrogen-dependent pathways to change behavior, right? So that's something that you want to think when you are doing molecular studies and when we are thinking about new drugs. However, we are here talking about women's health, and I think the question here, how do we make this work more translational? So I think what is really important to mention here, I think we have something very rare here, and this is like a construct validity of the animal model, right? Why this is the case? Because here, this is not an animal model, it's actually a physiology, right? So if something happened in humans and in mice, and this also, like increases the risk, you're literally having the actual thing happening in mice that is happening in humans, of course, with a more complexity. When we take a look at behavior, we are also seeing a lot of similarities. So for instance, as I told you, whenever you have a drop in ovarian hormones in humans and in mice, you see increase in anxiety and depression indices. I'm going to show also some data from Julia Sacher, who is coming here, because I think it's really nice to see what we are seeing in mice, these changes in brain structure across the cycle. Julia actually showed across the menstrual cycle in humans, where there are changes in gray matter that are really driven by the hormones. So we have the similarity in the hippocampus of mice and humans. So we were like, okay, let's do some cellular and molecular characterization of the postmortem human brain, but we decided to actually focus on the menopausal transition because this is when you see the biggest shift in hormones, and also there is a risk for depression that increases 2 to 5 times, okay? And of course, we wanted to do our cellular characterization, chromatin characterization, compare our data to mice. But then it turned out that basically the brain banks do not have the information about their reproductive state at all, right? So you can order the brains from people, but you don't know if they were menopausal or not. So we're like, okay, so we start from finding the proxies of the reproductive state. So what we did, we actually teamed up with Stefano Marenko, who is the director of NIMH Brain Bank. And we got the tissue from 42 individuals. I also want to say these are women and other people with ovaries. And we have people that are non-binary. So I just want to mention that it's important to use the right language when you request the tissue. So we took blood, plasma, hypothalamus, pituitary gland. We had 39 candidate biomarkers, 14 steroid hormones, blood and pituitary FSH, AMH, which is like the marker for the ovarian follicle reserve, hypothalamic and pituitary gene expression. And what we did, basically, we had 10 people that were less than 40 years old, 11 people that were more than 50 years old, and then our target population, the most difficult one, I belong to this, 45 to 55 years old, right? We also had some MDD cases, which was also nice, but the idea was that we take this pre and postmenopausal, groups, and then we try for this most difficult group to realize whether they are more pre or postmenopausal like, so that we can study their biology, right? Because the chronological age really doesn't tell you much about the menopausal status, right? But for this group. So we found 13 important markers, but 7 of these markers were really the strongest one. So blood, progesterone, blood estradiol, progesterone blood, and blood AMH, both you can see fall very nicely across the menopausal transition. Then we also see that blood FSH actually goes up because there's a compensation when ovary stops working. The pituitary is trying to actually compensate for that. We also see a very nice correlation between blood and hypothalamic estradiol. This is also very important because there are a lot of brain banks that do not have blood. And then we also have a very nice correlation between blood FSH and FSH in pituitary gland, which is also interesting because you can use pituitary gland to actually infer the status. However, if you take a look, none of these actually measures was really completely perfect, right? There was always some overlap between pre and postmenopausal. So we were thinking, what we try to do the composite measure, right? Something that will be representative of everything. So what we did, we actually found that these 7 markers were highly correlated with each other. And we did a principal component analysis where we were able to show that you can find one component score that actually accounts for all the 7 variables. And what was also important for us, that there is like a complete distinction between pre and postmenopausal group if you use this component, right? So you can take our perimenopausal group and say, okay, these are premenopausal like, and these are postmenopausal like. It's like a perfect distinction, right? So now we figured out the proxies, but and now we have this big task of doing cellular and molecular characterization of postmortem human brains. But I do want to just show you before we, what we did in terms of some kind of a study that we did. So we actually performed pilot studies of single cell chromatin and gene expression analysis both in mice and humans. And we were able to show that there are very similar cellular profiles of the hippocampus of the high estrogenic mouse and high estrogenic human. And then what we also tried to do, we actually put together mouse and human data and try to see whether they will cluster together, just to see how similar or different they are. And you indeed can actually make them cluster together, right? So we see conserved major cell type between common cell type between mice and humans, and some also divergent features, of course. But that means that we can use humans and mice data and actually to make some kind of parallels. So what we learn today, and I'm sorry that I'm a little bit, I was a little, like technically challenged here. Ovarian hormone fluctuation is a major psychiatric risk factor, and the estrous cycle matters for neuroscience. There are extensive chromatin organizational changes across the cycle that at least partially overlap with gene expression changes, which means that they're important for gene regulation. We are able to go from genomic data generated using physiological mouse model to in vivo mouse manipulation study to validate chromatin regulator and potential drug targets, and this is important. Similarities of the neurobehavioral effects of the reproductive cycle in mice and humans are remarkable, but we still need to do molecular characterization of the postmortem human brain to prove relevant changes in the human brain. Inclusive language generates inclusive data. And I would just like to acknowledge my lab, Devin Rox, Maria Tikerhoff, Ivana Jaric, who actually, the majority of data were done by them, Dr. John Greeley, Masako Suzuki, and NIH and Brain and Behavior Research Foundation for their support. And thank you so much.
Just one question.
Really interesting talk. I really liked the end where you're looking at the postmortem and trying to predict where they, like what the hormone levels were. What were the way that you measured in the brain? Like you said, hypothalamus, like what region and how did you look at expression?
Yeah, this is a very good question, right? Because I think we are actually preparing, this is going to be a methods paper that we are going to put out there. So it is really important because hypothalamus is a very heterogeneous region. If you, and the problem with when you do with mice, you dissect the area, but if you request this from the brain bank, they cannot promise anything to you, right? So why it's also important for us, if we do gene expression, it's very different, like, because I think because of the dissection that are very not really unique, but somehow for the hormonal levels, regardless where you take that, it was actually still the case. We do the mass spec though, right? So it's just like we get whatever we get, we prepare the extract and then we send for mass spec, so it's working really.
All right, I'm going to talk to you later.
Okay, good.
Thank you so much to Marija. And now it's my great pleasure to welcome to the stage Dr. Benicio Frey. It is from McMaster University to talk about not the epigenome, but understanding the biopsychosocial mechanisms of premenstrual dysphoric disorder. I'm so excited to hear what he has to say. Thank you, Benicio.
Thank you so much, Lisa. And please don't start because I really want to take a moment to, congratulate CAMH and womenmind for this incredible conference. Congratulate you on, being a star, stealing hers, from UBC was a great move. And of course, everything else that you do as far as advocacy in women's health. So congratulations on that. And thanks for having me here today. So I'm a clinician scientist by training and by heart. So I'll take like a little, research and clinical spin here after two incredible neurobiological talks that we learned so much. And I'm just around the corner outside of the other side of the Lake Ontario here at McMaster University, about an hour or 3 hours away from Toronto, depending on Gardner. Very good. So I have no conflicts to declare. So my learning objectives today will be for us to review and discuss the biopsychosocial mechanisms of PMDD, the links between the mechanisms and current treatments, and also some clinical and research gaps in this area. So I love to bring real cases because they really illustrate, the challenge that we face and why we're here. So this is a patient I saw yesterday. So these calendars I got yesterday, and she gave me permission. She goes by she, by the way. She gave me permission to, use anonymously for educational purposes. And this is a patient that I've been seeing for about a year now. And the story is late 40s, PMDD, well-established, well-diagnosed, 2 months prospective charting and all that. Comorbidity of depression, recurrent depression and anxiety, high functional, and excellent responder to SSRI for, decades. And then after the last pregnancy, so for some reason, the SSRIs have been partially effective. So I get the referral from the family doctor, someone with progressive worsening of general mental health with major concern of premenstrual worsening. So this is the calendar that last time I saw her before yesterday in mid-February. You can see the bleeding pattern, and then you can see the force is moderate by, the DRSP. 5 is severe, 6 is extreme, 1, 2, 3 is subclinical. So you can see a clear premenstrual component, but you can also see other challenging periods outside of menstrual period because this person has a comorbid condition. So we made some medication adjustments then, and then, in March, her calendar shows, major improvement. She thought she was really happy about it. Just 1 day of challenge, that was something that she was very happy about. And then yesterday I saw her, and then this is her calendar for April 16. Again, the PMDD is coming back. So this has been a recurring theme in her life right now, that some months are better, some months are worse. I saw her already off treatment, and then every month is worse. So there's a partial improvement here. We tried oral contraceptives. She felt worse. So worse, she has that subtype of worse with use of oral contraceptives. Went to talk to Dr. Shea, our incredible gynecologist, consulted at Women's Health Concerns Clinic for Lupron injection. Maybe it was too much. She didn't want, the potential side effects from the Lupron. So now we're making some further medication attempts with her. So just a case to illustrate some of the challenges we're talking about here. So when we talk about the bio from biopsychosocial, mostly we start with the genetic risk. This is an unmodifiable risk factor. We're born with that risk. So already old knowledge. If you look at family studies, premenstrual syndrome, premenstrual mood worsening, they run in families, quote unquote. Twin studies show higher concordance rates in monozygotic twins compared to dizygotic twins. So there is a clear genetic component to it. But the heritability estimates are between 35 and 56, similar to, major depressive disorder. So there is a genetic component, but there is also a large component that is not accounted for the genetic variance. This is not heritability estimates that we see, for instance, in bipolar disorder, schizophrenia, Alzheimer's, ADHD, that is much higher than that. And then as far as hormonal sensitivity, like I really use this term more and more these days when I explain to patient what's happening, because there's a lot of self-blame, there's a lot of major societal and social challenges that they face. They tell us every time. It is well known now that PMDD is triggered by the hormonal fluctuation. I would caution people about, increase or decrease or withdrawal, okay? Because now we have enough evidence, in my opinion, that it's about delta. It's about the fluctuation, not just about going up, not just about going down, but the fluctuations seem to disturb the cells and the brain to be overreacting in that percentage of the population that has that vulnerability. And PMDD seems to be then a result of an abnormal brain response to normal fluctuations, of hormones across the menstrual cycle. So there's nothing wrong about their hormonal levels. Maybe allopregnolone is higher, but estrogen and progesterone, LH, FSH are not. So this is the seminal study of NIMH, Dr. Schmidt and colleagues, showing that you do the leuprolide injection, you block the ovaries from functioning, it blocks the monthly worsening of PMDD symptoms. Then you keep that injection ongoing to block the endogenous hormones from interfering with the research. And then you give them estrogen, symptoms get worse. You stop, you give them progesterone, the symptoms get worse. But then you do the same challenging people that have not had a history of, I don't like the normal here, okay, this is from the paper, people with no history of PMDD, but then nothing happens. So it is about a subset of people that have that hormonal sensitivity to develop those symptoms upon hormonal challenge. And then the same group 20 years later showed us that it's not just about the use of the hormone that triggers the symptoms, because if this time around, they cap those individuals using the same hormone for 3 months. By the way, this is a different cohort 20 years later, so they replicated that study. And then again, it's about the delta. So only when they came from placebo to the hormone that the symptoms started, that the symptoms worsened. But those individuals were kept in the same hormonal treatment, and then eventually the symptoms subsided when the hormonal levels are kept the same. So again, it's about the delta. It's not the hormones action themselves. It's very important to understand in the biopsychosocial model that we all of us here in this room have estrogen and progesterone receptors in the brain, even though they're secreted in the periphery. They are more densely located in the limbic system. So areas that are associated with HPG axis, HPA axis, emotional regulation, stress response. This is the areas that more commonly are human beings have estrogen and progesterone receptors, so it's important for us to understand that. There are many models of hormonal sensitivity out there. This is, I think, a really nice review of neuroimaging studies done by Dan that looked at the imaging across the menstrual cycle. And they show the window of vulnerability for the symptoms matches with, changes in the resting state functional connectivity in brain areas that you are most likely familiar with, associated with changes in autonomic and stress response, more risk for bias for memory of negative experience, so the negative bias that we also see in depression, and of course, more risk for negative affective response. Another topic in the bio model is pregnancies and age. Like, it's well known for a long time that pregnancies increase the risk for PMDD, and also age. Older individuals have more risk of developing more severe forms of PMDD. Mind you that age and pregnancy interact, because as the older you get, more likely you may have a pregnancy, but these are already known that are also independent phenomena. So it has been proposed that the exposure to high levels of the ovarian hormones during pregnancy prime the brain to actually be more reactive after pregnancies. And this is one of the potential reasons why we see that phenomena happen clinically, as I showed you one of the patients. And also, if we look at the hormonal dynamics from puberty to menopause, when the ovaries stop working, there are dynamic changes across the reproductive life stage that presumably and probably also cause some neuroplastic changes in the brain that down the road increase the risk for more severe forms of premenstrual disorders. Here's my animal model slide, Lisa. So, I'm just going to give you a couple of results here. So if you look at what estrogen does, both in rats and monkeys, okay, so estrogen blocks the monoamine oxidase A enzyme in the rodents and monkeys, and we know monoamine oxidase A is one of the enzymes that catabolize the catecholamines. So if we are blocking the MAOA, we are increasing the serotonin in the brain. And TPH is the tryptophan hydroxylase enzyme, which is the rate-limiting enzyme of the tryptophan pathway to serotonin synthesis. So if we're activating the tryptophan hydroxylase, we are increasing serotonin synthesis in the brain. And again, estrogen, both in rats and monkeys, increase the TPH activity. So if you in the room believe, like I believe, that monkeys are closer to us in the ecological chain and they're closer to, rats, I think there's a reasonable, it's a pretty reasonable evidence to believe that this is also conserved in our brain. Now from bio to psycho, mind you that biopsychosocial, they interact. I'm showing them separately, but they are absolutely linked, okay? Trauma, mood, and anxiety. So longitudinal studies show that trauma is a risk factor for subsequent PMDD. And we know elegant work that was just presented here in a couple of presentations that impact of early trauma has on both HPA and HPG axis. PMDD is highly comorbid with other conditions, primarily mood, anxiety, and PTSD. So this is just an example of a German study showing the odds ratio of all the comorbid conditions, and it struck me first time I saw that PTSD is actually the one with the greatest odds ratio for comorbidity with PMDD, and then bipolar disorder as well, which is an area that my group went into to study a little bit. Another important aspect of PMDD in the cycle part of the biopsychosocial is self-harm and suicide risk. You know, if we talk to people who live the experience, if we talk to people from, you know, International Association for Prevention of Disorders, PMDD Canada, and other, you know, incredible advocacy groups, you know, people want that the risk for suicidal ideation to be part of the DSM. They're pushing for the DSM to acknowledge that. And our group and others have looked at it, and there's a clear link between PMDD and suicidal ideation on the camp. Now, social discrimination is just one of the examples here. So this is a study of over 2,000 Asian, Latina, and Black premenopausal women aged 18 to 40. And all sorts of discrimination increased the odds of having PMDD, and the greatest odds were related to race and gender. So certainly work to be done in that space. And stress. So first time, I'll never forget, I didn't ask the patient permission, so I couldn't bring that calendar here, but you know, I was following a patient for PMDD, and then same treatment, and then one calendar was, you know, pretty clean and steady, no worsening, and then the other calendar next month, like pretty significant PMDD worsening, similar to the case that I showed you before, but was a different case. And then I asked the patient, why did this happen? Like, you know, we're the same treatment, and you know, what's your take? This is the stress that month. So the patient works in a busy law firm. That month was so hard for all of us staff, deadlines, and the stress was up across the board. So work stress, you know, interacted with the person's biology to increase the PMDD symptoms, which then subsided after that month of work stress. And then this study here of over 1,000 young women that were prospective followed show that elevated daily hassle score. So, you know, stressful life events increase the odds of the risk of PMDD. So now to the, you know, tail end of my presentation here from, you know, the biopsychosocial model to treatment. You know, when you see this slide, I didn't want to ignore the studies that were done in a randomized fashion. So these are some of the studies, compounds and treatments that were attempt to use, you know, a randomized design. And one diet trial that was carbohydrate rich, but really what was happening in that diet, if you read the paper, is that it's increasing tryptophan absorption, so presumably increasing, you know, serotonin synthesis in the brain. Exercise, psychotherapy, CBT has been shown to help people. 5 minutes, I'll be on time. Thank you. And then vitamin B6, there's one trial against placebo, Calcio 600 BID. And then there's this extract, the chaseberry extract, which, you know, Dr. Gali and I have been talking about in terms of trying to understand its mechanisms, you know, seem to help some people. But largely, if you read those papers, these are not severe PMDD cases or moderate to severe PMDD cases. These are usually, you know, cases with mild forms of PMDD or even PMS. So just be careful with that. But when it comes to, you know, moderate to severe cases, this is what we got. So we have serotonin-based drugs, and we have combined oral contraceptives, and that's pretty much it. If you want to go beyond that, then you have to block the ovaries from working, either with an injection or with, you know, oophorectomy, which in my 15, 16 years now of work at the Women's Health Concerns Clinic, I only saw one case that was considered. This is really, really rare. But I do share with Dr. Shea, a gynecologist, a lot of patients that are on Lupron injection, because that was the last resort. So clearly, you know, there's a lot of work to be done here, and I'll give you away some of the clinical and research gaps, and this is the end of my talk. So this is just a short list of many things that we can do, and I'm excited to hear more from other speakers about that. other pathways, like we have to go beyond hormones and serotonin pathways. The allopregnanolone story, I like it. I trust it. In one of our studies, both that we published, both in the follicular and the late luteal phase, allopregnanolone levels were up in the blood, which wasn't something new. We just replicated other people's work. But unfortunately, the larger trials that we've seen, there are a couple, and we have experts in the room here, didn't quite make that, clinical path that we would love to see in terms of, a new compound that can help people clinically. Neurostimulation, I argue, is this something that we should invest? Can we reverse this hormonal sensitivity? Can we develop something to actually reverse that in the brain and actually make people not react that way? Can we move towards that? Can we look at safer treatments? Because, hormones have, a lot of safety concerns and thrombosis and cancer and all that. Can we develop safer treatments? What about PMDD subtypes? I just gave you a couple of examples of people with different, profiles, and you see that those that love the hormone treatment and those who hate the hormone treatment. So clearly, there are subtypes that we need to understand. On the psychological aspect, early trauma adversity, I think this is, I know there's a lot of people doing that work right now. It's very exciting. So I look forward to seeing the results of that research. Emotion regulation, DBT, I think it's something that is going to grow in this area. How do we build resilience to stress? Very important. Stress does worsen the sensitivity. Psychoeducation, what kind of education? Where? So I've been talking to, Simone, Lisa, Daisy about, perhaps having, and Patricia, and perhaps having a place where we can have all the information in one place. So, so we can all, feed one place. And this is where we all should refer patients and students to go. Support, we can't do enough advocacy. I mentioned, womenmind, IAPMD, PMDD Canada, and, obviously there are so many foundations, Daymark Foundation, St. Joe's Foundation, Sun Life, Shoppers Drug Mart, Run for Women, like, the list goes on and on. Professional training is very important. I can rant the whole day here how our clinic is neglected, like we are not core rotation for psychiatry, but I'm happy to say that we're now core rotation for family medicine, which is incredible. Advocacy, public education, access to treatment, our patients say that every time, and other social determinants of health, of course. And to finalize, I just gave a snapshot of PMDD, because this is one of the areas that I love to study and work. But mind you that this PMDD is in a continuum of many other challenges related to hormonal sensitivity. And just a month ago, we saw this beautiful paper from Sweden actually showing the bilateral relationship between risk of PMDD developing postpartum depression and people that develop postpartum depression have a risk of developing PMDD after that. So there is a well-established since last month relationship that now nobody can argue against. So thank you so much. I appreciate it.
It's on already. Apparently that side of the room, I think, can't hear very well, so they're gonna switch out the speaker, so we're sorry about that. I'm gonna ask Yulia to speak loudly into the microphone, and we have time. I really want to ask a bunch of questions. This is a very hard, you have to choose.
No,
Between the two, Jillian? Yeah.
please.
Thank you.
So my eye caught one very specific part of your excellent talk, which is the last resort treatments for PMDD, which is either ovarian hormone suppression or ovarian removal. And I'm just wondering if you could discuss a little bit what the thinking behind that is, why that would be beneficial, and also what the evidence is that it's actually beneficial.
Yeah, so, oops, sorry. Thank you. There are, studies showing that the suppression of ovarian function with Lupron and the estrogen and progesterone add back can help alleviating the monthly worsening of PMDD. It's also in the ACOG guidelines and many other, recommended clinical practice papers out there. Clinical experience, I think, is also show that some individuals, they do benefit from it. And what is the good news about the Lupron injection is that it's not like a permanent damage. Okay, so if something goes wrong and then there are side effects, it's something that, people don't tolerate, you can stop the treatment and the ovaries come back to life again. Oophorectomy, I think it's, way too invasive because it's permanent. Quite often decisions are made out of desperation either from patients or clinicians that don't know what to do. Like I said, I saw only one case that we even alluded that possibility with the patient and their family, but I would certainly, stay away from that. But I do think Lupron injection has a place. Thank you. Simone, you had your hand up? Oh, you don't have time? Oh. Thank you.
I'm so sorry because we need more. Thank you. Now it's my pleasure to introduce Yulia Sacher, and apparently I say it wrong. It was okay.
Oh my God, wonderful.
It's a cake in Austria. Is that
Yes.
true? And
Famous cake in Austria.
famous cake in Austria. She's no stranger to CAMH, but she's now at the University of Leipzig and Max Planck Institute for Human Cognition and Brain Science.
Well, thank you so much, Lisa, for spearheading this incredible program. Is that okay with the mic? For inviting me to come speak at the first Women Mind conference, and also to help me explain the weird title of my talk that you inspired with a previous presentation you gave, as you've tirelessly worked to build this incredible translational arch from bench to bedside to advance female mental health. But actually, I did work at CAMH way before Lisa. So from 2006 to 2009, I was a postdoc fellow with Jeff Meyer, who's also here, at his neurochemical imaging program for mood disorders at the Pet Center. And I loved working here. And this I found actually on the flight here. It's the first photo saved on my smartphone that I took really sadly when I was leaving Toronto, because again, I loved working here. And while the Max Planck Institute and the clinic in Leipzig also looks really pretty in spring, and it's been a great research environment, I really miss Toronto, but I had to embark on several personal stress experiments that could only be conducted in Germany. And we definitely had our fair share of stress paradigms to handle as two scientists, a biologist and an MD PhD, trying to balance family and work, including some really unexpected results. But they've been great in supporting me to get my own research program going. And so I feel very thankful, grateful, and privileged to be here. And we've always hoped to make a contribution towards preventing depression and improving antidepressive treatment, with really the ultimate goal to maintain emotional well-being, cognitive health across the lifespan, which really piggybacks on what Benicio just outlined for you. In my research group of cognitive neuroendocrinology, we aim to explore the impact of sex hormones on brain and behavior. And one way to do this, the way we chose to embark on this, is to look at hormonal transition periods, both as a model of risk, but also as a model for opportunity. All the people who've spoken before me have already said this, and I'm sure you've known this coming in. 2 to 3 times is actually, the higher prevalence rate that women suffer from in depressive illness compared to men. We all know this really alarming data that the World Health Organization predicted, and now we're even earlier. But it's one of the most robust epidemiological findings we have, relatively independent of cultural factors. But still, we know so little about the mechanisms underlying these findings. I'm very glad that I can be fast with this. You've already heard that it's not an absolute value of estradiol or some other ovarian hormone that is the problem, but it's more the fluctuations of the endogenous ovarian hormones across the female's own individual mean that is associated with this heightened risk. And we've heard from also the clinic that it's really during hormonal transition phases that psychiatric illnesses often get worse and that we see so many more new onset cases to appear. So I will not try to get into all of these aspects, but I'll give you 3 examples of our work for different hormonal phases. And I'll start with the work I was so privileged to embark on at CAMH more than 15 years ago. We looked at the immediate postpartum period just because that's when the most dramatic changes happened. With the loss of placenta, estradiol levels go down 500 to 1,000-fold. And postpartum depression, I mean, it was underdiagnosed and undertreated. It still is. It affects up to, the numbers range from 13 to 15, some say 20%. Anyway, it's considered the most common complication of childbearing. It's still really hard to get treatment. And I don't want to pitch one illness against another, but I've been doing work in this field for a while, and still the CDC statement really hit home for me, where they described that it was more women who will suffer from PPD and related illnesses in a year than the combined number of new cases for men and women to suffer from tuberculosis, leukemia, MS, Parkinson's, Alzheimer's, lupus, and epilepsy. So that really opened my eyes once again to the importance and the impact that this kind of work could have. And so it was actually the reason why I left Vienna, one of the most beautiful cities in the world where I trained and worked for a while. But I thought I really wanted to look at the neurobiology of this kind of the disease. And now there's this FDA-approved brexanolone treatment for postpartum, which is a fantastic example of translational work. But back then, Jeff and the colleagues at the PET Center already argued and saw the value of developing traces for this target that has been introduced by Benicio already, MAO-A, this enzyme breaking down monoamine, serotonin, dopamine, noradrenaline. So a really powerful gatekeeper of mood in the living human brain. And I didn't have the training to look at knockout models or epigenetics, but we really thought, like, can we look at the actual living human brain? And you can do that with positron emission tomography, and you have some of the experts here in this room to talk more about this. Back then, everybody told me that this was impossible. I mean, you cannot inject a radioactive tracer in a woman who's given birth 3 days ago, and who might want to nurse her baby. But with this incredible team at CAMH, they said, well, let's try. Let's try. And we had this fantastic multi-professional background, people from radiochemistry, like killing themselves to make this tracer in time to adapt to due dates that were ever changing. Really supportive clinical staff. I was from Austria. It took me a while to get my license approved here in Toronto. A young psychiatry resident whom some of you may know by Aristotle helped me with pulling arterial lines because MAO-A is everywhere, so you don't have a reference region. And so this is quite invasive. But that was also a really beautiful thing we learned with the women, right, who after giving birth couldn't care less about putting in an arterial line. So we learned a lot during the study. We had meticulous safety measurements to make sure it was safe for the parents, but also the infants. And I also want to introduce one of the most crucial people who I'm not sure if she also taught Tom Cruise how to fly for Top Gun, but I was lucky enough, and she's here in the audience today, that she toured all of the Greater Toronto area with me to attend every single Mommy and Me, every doula event, to get the word out about this work. And we found so many women who were really enthusiastic about participating in this kind of research. And I really think that the team effort was worth it. We were really surprised about this. You've heard that estradiol and MAO-A have this inverse relationship. So we were hoping that we would see an increase in MAO-A when estradiol levels went down. we saw a 40% increase with, if you know about PET effect sizes, was really, really unexpected and quite dramatic. And what you see in red and gray is the follow-up clinical work in actual women with postpartum depression later on. And you can still see elevated MAOA levels across the human brain in these women. And this monoaminergic loss may actually explain the depressed mood that they experience. But what we also see, and I think this is where we need to push further and we need to ask more questions, is this overlap between healthy women who were really doing fine and women who were in the midst of a strong clinical episode. So, sorry, I don't want to skip this. Because what we believe is really important is that we have to reflect the spectrum, right? It's not binary. This is a continuous spectrum, and we need to do better in offering prevention and treatment, right? And I think what we learned then is like a reversible MAOA inhibitor can be a really powerful tool clinically for a very severe case. But I think Jeff will talk about his newest findings tomorrow. That is perfect timing, I think, for this conference. That is really a nutritional supplement work that has come out of this long line of his research program. And that is a very exciting development for someone who's probably not in the midst of a depressive episode, but has had maybe a previous episode of family risk and doesn't want to go like on the most, is maybe scared of the side effects of MAOA inhibitors, but wants to embark on some preventive strategies. Second example I'm giving and I'm sharing is actually the one I think I'm supposed to be talking about here is the menstrual cycle. We've heard a lot already about the importance of those subtle endogenous ovarian changes. And we had the chance to look at this in health and in PMDD. Fantastic work by my predecessor has already set the stage for these data. What we did was another PET study, this time in Leipzig, with a tracer that's easier to handle, no arterial lines, so it can be done somewhere else than CAMH. And we acquired a periovulatory and a premenstrual scan. And these women were meticulously followed. So we did vaginal ultrasounds to make sure that we were at the right phase. This longitudinal tracking and PET scanning was also challenging. But what we found was really the significant increase in serotonin transport protein from periovulatory to menstrual phase. Now, you all know that SSRIs are the standard treatment for this disease. However, in Germany, for instance, many women are reluctant to try it. Many gynecologists don't know about it. Many psychiatrists don't know about it because they don't see those patients. So there's a lot of like psychoeducational work to do. But I think what this was really, really interesting for is to understand the mechanism and actually have a biomarker that lays the groundwork for the luteal dosing that can be super effective in a lot of women who are reluctant on being on an SSRI for the entirety of their reproductive years, but may actually consider taking this drug for a couple of days, particularly if they're experiencing symptoms like my colleague before showed. And of course, there's also perspective towards developing dietary supplements and serotonergic precursor substances as based on the data that Benicio showed. What we also dove in was healthy female brains, because when I was preparing for the PMDD study, I mean, there were some lines of research, of course, but in the neuroimaging field and in the high field MR, because, I was at the Max Planck, I had all these fantastic devices, but it was always male brains. And it was a very exciting time for neuroplasticity research, but we were wondering, looking at Lisa's data and other people in the field who showed this in rodents and who like this neuroplasticity findings in the 60s, right? Were also by a female scientist, Marianne Diamond in Science. And she already got the feedback that I got 50 years later, like, no, young lady, this is not how the brain works. It doesn't change that fast in adults. Well, we found it does. And this is on a really strong magnet, 7 Tesla. So all the Max Planck researchers actually listened this time. And again, we did the meticulous menstrual cycle monitoring ovulatory and vaginal ultrasounds, all the blood work. So we're really in that to those women who like took this ordeal on them to come in for 6 longitudinal scans. And we found hippocampal subfield changes that were in the effect size of biomarkers the neuroimaging community gets really excited about as predictors for early risk and dementia. But we saw these in young, healthy women. And the question is like, what is adaptive? What is neuroplasticity? And what is required in health? And are those changes bad or good? And what are the experiments that we have to design to answer these questions and really move the needle towards precision medicine? And in interest of the time, I'm trying to move on and get to the third example, which is sex differences in metabolic risk and brain health across the lifespan. I don't have to tell you the problem that dementia poses in our aging societies. And here also, it's 70% of Alzheimer's patients are female. And it's also becoming clear that obesity seems to play a crucial role in how our brain ages and how well we maintain cognitive function as we age. However, it's super challenging to get the participants you actually want to be looking at for early risk and prevention into a scanner in the midst of their lives. They're juggling family, work, care for their parents, but we really need those data because the first metabolic abnormalities, first neurodegenerative processes begin 20 to 30 years before we see clinical manifestation of this disease in a patient. And we had the beautiful chance to do this in a study called LIFE, which focuses on civilization-based diseases like dementia and depression, diabetes in Leipzig, a German city that started a peaceful revolution that brought down the German wall. And so this was a very interesting historic place. And we felt that it was a very special study because, of course, people were really reluctant for a good reason to participate in this kind of research and share their personal data. But we have data sets of more than 10,000 participants now with the age range from 20 to 80. And for the analysis I'm going to show you, I'm just going to present the MR, so the brain data, and the belly MR data for 1,000 subjects. So you're probably used to looking at this. This is a brain scan from a patient with medial temporal atrophy, so a patient with dementia. But I'm not sure I'm not sure if Neil has looked at abdominal MRIs of bellies yet. And you can see red and blue tissue. So we separated the fat into organ fat, visceral fat, and subcutaneous fat. Because all my internal medicine colleagues and all the endocrinologists told me how important looking at inflammatory load for the brain was, and how they actually considered this thing in red here their own problematic inflammatory organ. Now, I typically get the question, well, everybody can calculate BMI on a smartphone. Like, why would you do this? Because we manually had to segment the first 100 before we could automate it. And it was a nightmare. But this is why. You see 2 men at the top, 2 women at the bottom, and they're matched for age and for BMI, but they have dramatically different visceral fat ratios compared to subcutaneous fat. And if we believe that visceral fat is a risk factor for brain atrophy, those individuals may have dramatically different brain aging trajectories. And we actually have the evidence to believe that this might be the case. Visceral fat is a risk factor for metabolic disease, but also, and in the interest of time, I'm moving on here, but it's also really a problem for brain damage. And so what we did in this LIFE cohort was we looked at the integrity of brain structural brain matter networks. We looked at volume, we looked at cortical thickness, at surface area, and we found this inverse relationship between visceral fat and brain network integrity. More fat, less brain integrity. That's not new. Other groups have shown this. We replicated it in a network that's functionally relevant. Really strong associations between this network published in PNAS and cognitive function, memory. And we found substantial sex differences in the signal that nobody was talking about. everybody kind of thought that this is clear, right? Men have different belly shapes than women. So they tend to accumulate visceral fat earlier, which also is a problem. Women in red have this weird inflection point at the age of 47, right when perimenopause hits, right? And so at the first look, this looks actually good for women because this relationship, right, between visceral fat and brain seems to be dampened a little bit, and maybe it's endogenous estradiol. It makes sense with the animal literature, but the problem is that, right, when women are losing this endogenous protective factor, they're accumulating visceral fat exponentially. And so this is one of the data sets where I think we have a really strong claim to emphasize the importance of looking at perimenopausal transitions of brains in big data cohorts, because the effects of ovarian aging go way beyond chronobiological aging. And looking at the perimenopause as a critical neurological transition state may actually really move the needle towards personalized medicine in neurodegenerative diseases. Yes, and if we learn more about this, we may be able to intervene before disease susceptible state tips into an irreversible pathology. But it's not just metabolic risk that is problematic, right, for brain health, also cardiovascular risk. And that is not my field, but I know that this is one of the pioneering fields of sex and gender medicine. So when I was asked to review this really cool data set, like more than 40,000 brain imaging sets and cardiac MR sets, so really cool feat, I was shocked that they never considered sex in any of the original analysis. But the editors were really, really lovely, and they actually asked us to comment. They made them revise a lot of their analysis, so data is much better now. But I think it's a really important topic that could bias such mega-analysis, and I think it has been brought to your attention before, that however fancy, right, the analysis approaches get, and the enormous data sets, and we've done a fair bit on this, and it is cool, and I think it's important, but the data are just as good as what went in there, right, the information. And if the original information is biased, so will be the results. And so we are guilty of this too. I mean, those are fantastic colleagues, and we looked at human connectome data, UK Biobank, and then there's a German national cohort. And high impact papers and editorials love these sort of data sets, right? So both of them did tremendous work, and in the final process of getting maybe their papers into Nature Communications and Science Advances, which is great, but I think they would be the first, including Emily, who's here, one of my students. Take a look at her poster 24, who works with a Charité database of clinical samples and really enormous MRI data as well. But there is a problem, and I think Marija also said it, like you can't get the information that you want because those paradigms have not been designed to look at these questions, right? And they might include female, male, and maybe perimenopause, or maybe intake of oral contraceptives, but that is not enough to ask the fine-grained questions that we kind of have to ask. So I'll end my talk with this problem of missing data. And while I'd be happy to, in a discussion, address all that, the typical question I get at the end of my talk is, no more, young lady, it's more like, you're still here, you're still not doing men, like, what is the problem, Julia? Like, are you not interested in male brains? And I am. I have 2 sons, I have a husband, I've had fantastic male colleagues along the way. And I think that it's a huge problem that our social construct of gender traditionally, and I don't think that's just Germany, teaches boys that the expression of emotion is weakness, and that these harmful expectations of masculinity have impossibly harmful effects on male behavior and their interacting others. And I really like this documentary, Beyond Man and Masculinity, that I made both my sons and my husband watch, that actually addresses difficult emotions like shame, anger, and the transmission of patriarchy. And it facilitates a really interesting dialogue around power relationships diversity in gender expression, and mental health. And we should absolutely talk more about these male feelings and brains and behaviors, but this is not today's topic. This huge data gap we're facing does not concern males. It concerns the other 51% of our population. And very recently, Lisa and her team looked at this with emphasis on neuroscience and psychiatry. And psychiatry does a little better than the neurosciences. So CAMH is better off than Max Planck, I feel. But it's still astounding that after the NIH mandate and all the time that has passed, only 4% of neuroscience papers looked at sex as a discovery variable. So we know the time alone won't fix this. And we can look at this as a human rights issue, as sex and gender equity, and a matter of justice. We can look at this if we're trying to get funding, right? And addressing this problem is crucial to providing the best research. And that typically also flies with Max Planck. Like, you need this to thrive for excellence in research. But ultimately, though, this is fundamental to providing the best care for our patients, which concerns all of us, as treating physicians, healthcare providers, as family members, and sometimes even more stigmatized as patients ourselves. So you probably know that the majority of drugs, which is not limited to psychiatry, are withdrawn from the market because of side effects that occur in females. Maybe I want to be inclusive, women, whoever identifies as such, right? Because they're usually still developed in male animals, and they're still often disproportionately tested in male patients, prescribed to female patients. Recent example, lecanemab. Super exciting Alzheimer drug, right? But if you look at the data and you look at the supplements, it works in Caucasian males. It's not supported in females. It's not supported in people of color. So this needs to change. I know that all of you in this room do not need to be convinced by me, but how do we convince the researchers, the healthcare providers, the policymakers outside of this room? And this is why we're so excited about this CAMH womenmind program, continuously supported by, now I know how to pronounce it, I hope, Trailing Family. Thank you, Aristotle. And inspired by this initiative, we actually got funding to found a center like this dedicated to a similar mission in Leipzig. But I want to put this idea out there that we need sister hubs. So we want to form sister hubs with CAMH womenmind. I'm flying to Boston tomorrow to speak at ICON-X, which is this Harvard Innovation Center of Sex Differences in Medicine, because they will also join forces with us. And I would absolutely be thrilled to talk to many of you to form additional sister hubs. And I cannot end, sorry, Lisa, before I thank my rockstar team of students and trainees for their outstanding work, our collaborators and investors, and of course you for having me and for bearing with me until now, until this session that's running far too late. Thank you.